Voyager 1, the first spacecraft to travel beyond our solar system and reach interstellar space. Almost 45 years ago, it was sent into space on September 5th, 1977. Now, it is about 23.5 billion kilometers away from Earth, making it the spacecraft that is currently the furthest away from our home planet. Today's video is all about the journey of the Voyager 1 spacecraft, which just reached a distance that no other human-made objects have ever done before. We will take a look at its history, its accomplishments, and more importantly, its terrifying new discovery. So make sure to watch the video till the very end, and if you're new to the channel, make sure to subscribe to the channel and hit that bell icon so you don't miss any of our future videos. So without further ado, let's get into the video. The Voyager system is one of the most advanced deep space probe systems ever created. Voyager is outfitted with computer programming for self-protection against falls. There are 7 top-level fault prevention processes, each of which can handle a wide range of potential failures. The spacecraft can put itself in a safe condition in seconds or minutes, which is important for survival when the spacecraft travels to the far reaches of our solar system, where round-trip communication duration with Earth can take several hours. Prior to Voyager, we knew very little about the huge planets Jupiter, Saturn, Uranus, and Neptune, having only visited Jupiter twice and Saturn once by human probes. There was a lot we didn't know about these 4 planets, like what were they made of, if they had any moons, what was their magnetic field like, and whether or not they had rings. Gary Flandreau, an intern at the Jet Propulsion Laboratories, discovered in the late 1970s that the 4 outermost planets will be aligned, which will be the opportunity that happened in 3 lives. So it seemed evident that a single probe could complete the Grand Tour, harnessing the gravity of one planet to go to the next on a gravity-assisted trajectory. However, as planetary exploration funds were cut, the first proposal was deemed too expensive, and so a race was on to discover a less expensive alternative, while still taking advantage of the uncommon planetary alignment. To replace the original concept, it was decided that a pair of identical probes were to be created, and the new mission was called Voyager. Voyager 1 was designed to travel close to Jupiter and Saturn, whereas Voyager 2 would pass these planets at a little wider distance and then continue on its own path to Uranus and Neptune. The twin probes weighed 722 kilograms each and were loaded with scientific instrumentation, radio systems, and power sources. Given that Voyager 1 will be traveling 778 million kilometers from the Sun, solar energy was not a possibility. The best choice was to use nuclear power in the form of radioisotope thermoelectric generators, or RTGs, with plutonium-234 that broke down to make heat, which was then turned into electricity. Voyager 1 is equipped with 11 instruments for analysis. It can look at things like the chemistry of the atmosphere, magnetic fields, identify aurorae, measuring charged particles, using radio waves to estimate the shape of a planet, and measuring plasma to find solar wind. Voyager 1 launched on September 5th, 1977, after Voyager 2. Voyager 2 was required to go further to the 2 outermost planets, so it was launched first. Surprisingly, Voyager 1 overtook Voyager 2 before Jupiter. When Voyager 1 finally reached Jupiter after a 15-month trip, and scientists found evidence that the Io, one of its moons, exhibited geological activity, a property previously attributed solely to Earth. Io is the most geologically active place in the solar system, despite being only a third the size of Earth, but producing twice as much energy from its volcanoes. Also, Voyager data showed that Jupiter's magnetosphere extends all the way to Saturn's orbit, which was a major surprise. Jupiter's infrared spectrum revealed that it was mostly composed of hydrogen, with minor quantities of helium, water, methane, ammonia, and rock. Following the closest approach, Voyager 1 took another incredible picture. It showed a small ring circumscribing the planet very closely, which was previously considered impossible for Jupiter to maintain. Its black stony grains spurred theories that the ring was formed from the fragments of a long-dead moon, much like the recently found moons Phoebe, Metis, and Adrastea. Ganymede, the biggest satellite in the solar system, was also found to have a very thin atmosphere, even though its surface is full of craters. Moving forward to Saturn, the Voyager's team's findings around Saturn began with a flyby of Titan, one of Saturn's moons. Voyager 1's passage through the planet Orange Cloud confirmed that the planet's thick atmosphere was far denser than previously thought. Titan had previously been assumed to be the biggest moon in the solar system, but radio signals revealed that its solid core is actually less in diameter than Jupiter's moon Ganymede. Titan, much like Earth, has an axial tilt, which allowed Voyager 1 to observe seasonal changes caused by the flow of gases between Titan's two halves. Saturn's complex ring system was captured on camera by Voyager, with the help of the shepherd moons, Prometheus and Pandora, which created thin bands, spokes, and gaps. After completing its mission, Voyager 1 continued its journey towards the outer solar system, eventually surpassing Pioneer 10 as the furthest human-made object from the Sun. Prior to this in 1990, the probe snapped the now iconic photograph of Earth, the pale blue dot, as it glanced back towards our solar system. After that, Voyager 1's transmissions went silent until 2002, when it began picking up intense particles, suggesting that it had passed the solar system boundary at termination shock. At this border, the solar wind suddenly loses speed when it collides with interstellar winds, causing the particles to cluster together to a noticeable degree. After Voyager 1's Saturn flyby, the plasma detector most suited for sensing solar winds ceased functioning. Hence, it took nearly 2 years for the Voyager Interstellar mission team to confirm Voyager 1's position. 3 years later, Voyager 2 reached this area from a different place. This was more proof that our solar system is not round, but rather squashed. In 2012, Voyager 1 reached the heliopause, the border between our solar system and interstellar space, when the solar winds are pushed back around the heliosphere by the interstellar winds from the Milky Way and nearby supernovae. In its new role as humanity's first interstellar traveler, the legendary Voyager 1 has been gathering data on the heliosphere's crucial role in shielding our solar system from the harmful effects of 75% of galactic cosmic radiation on the ozone layer and DNA. From 2020 onward, the dwindling RTG power supply necessitates a gradual shutdown of the onboard scientific equipment. By 2025, all of the equipment will have been turned off, and for the next several years, it will only get sporadic, tiny electrical blips showing the whereabouts beyond the solar system. But the mission of Voyager 1 is far more than that. Despite Voyager 1's primary purpose of exploring the outer solar system, it may also be used by future civilizations to learn more about our home planet. Voyager 1 has installed a special 12-inch disc time capsule depicting Earth and humans with a lot of information. Instructions for reading the disc are inscribed on a gold-plated copper disc, and the probe also carries a sample of ultra-pure uranium-234, so that, once it becomes active, scientists may calculate the probe's age and map, showing the location of the Sun in relation to 14 known pulsars. After consulting with historians, artists, folklorists, and ethnomusicologists, Carl Sagan and SETI's Frank Drake selected the contents of the Golden Record, which included 116 analog encoded pictures, greetings in 55 languages, 12 minutes of natural noises from Earth, and 90 minutes of music. And last but certainly not least, the Voyager mission, which have been conducted over the course of the past 45 years, have played an essential role in the provision of useful information and have contributed to a shift in our understanding of the Sun and its effects in ways that no other spacecraft can. Both Voyagers are currently venturing through interstellar space, and as a result, they're providing humankind with observations of formerly unexplored regions. The next significant event for Voyager 1 will take place in 40,000 years, when the probe will approach the star AC +79 3888 to within 1.7 light-years of its distance. The distance between our planet and the star is approximately 17.5 light-years. However, because Voyager 1's power supply is decreasing, it is likely that the spacecraft will stop gathering scientific data around the year 2025. But still, it will carry the golden disc, and perhaps at some instant, alien civilization will get their hands on the disc and will give us a surprise visit. Who knows? Well, that's all for today's video, guys. What do you guys think of today's video? And what are your views about outer space? Do you think we'll ever be able to encounter an alien civilization in the near future? Tell us your views in the comment section below. Until next time, guys, take care.